Hello, and you're very welcome to this morning's Signpost webinar. We hope you're keeping safe and well wherever you're joining us from today. Today, we're going to be talking about peat grasslands. And as we know, soil carbon sequestration is an important mechanism that removes carbon dioxide from the air and stores it in the soil, improving a number of aspects of soil health. But peat grasslands in particular play a crucial role in carbon sequestration due to their unique characteristics. And to discuss this more and their implications and relation to our climate action plan, we're delighted to be joined by Dr. Patrick Tuohy, who is Senior Research Officer and Soil Hydrology Specialist based in Moorepark. Patrick, you're very welcome to this morning's webinar.
Thank you, Mark. Good morning. Good morning, everyone.
And good morning to you, Pat. Hope
Morning.
everything is well down in the sunny southeast.
Yeah, not quite sunny yet, but we're hopeful.
Okay. Hopefully this year at some point. So look, it is great to see that things are starting to dry out across the country, and we do hope the farmers of the country are feeling in slightly better spirits now that things are under up, please God. So Patrick, maybe you could tell us a little bit about the work that you're doing in Moorepark. You've quite a diverse portfolio there.
Yeah, thanks, Mark. Look, I suppose in the soil space, I've been working for a number of years with a number of colleagues, and managing soil hydrology, managing water table within soils, be that the drainage of mineral soils or the opposite of that, the rewetting and the water table management and some of the peat soils. And through that, I suppose we've had a look at the various different policies around the management of these soils and how we might be able to help provide some information that might help people's understanding of these soils and the management of these soils.
So we had a very nice introduction last week. We had Owen Fenton discussing soil hydrology, and today is a very nice follow-on from that, because obviously there's a huge focus on peatlands and their importance, particularly in terms of water, the ecosystem services in terms of carbon sequestration, but of course also water absorption and slowing down the water movement in our landscape is another dimension to that. But so you're kind of, I suppose, bridging the two areas to some degree today. So look, Pat, we'll let you, you have some slides you want to have prepared, which is great. But before you do that, I just want to remind everybody that we do have the Q&A tab. For those of you who are new to the webinar, we have a Q&A tab at the bottom of the screen where you can submit your questions to Pat throughout the presentation. And today's session is being recorded and is available, will shortly be available on the Teagasc YouTube Signpost channel, as well as our podcast stream. And Pat's presentation will also be available on the Teagasc website in the coming days. So I think we'll hand over to you, Pat, and we'll take questions afterwards.
Okay, thank you, Mark. Yeah, so as we've said there, I wanted today to introduce a bit more detail around the management of the grassland peat soils. First, that definition, what are grassland peat soils, and that can be kind of difficult to grasp in terms of coming from different definitions or different stakeholders. So how we perceive that definition and how we're looking at managing these soils going forward. Some of the work that's been going on the last couple of years, some of that has had quite a big impact in terms of policy around these soils recently, and other projects that are looking at the future management of these soils. So what is peat, first of all, just to give the context again of broadly what we're talking about. An accumulation, peat is the accumulation of partially decomposed organic matter where high rainfall or impeded drainage causes waterlogging. So plants or animals or anything that was once living, if it is in a waterlogged scenario, when it dies, that there's a slowing or a much reduced rate of decomposition. So as a result, in waterlogged conditions where there's material living and dying and moving through that cycle, you get this buildup of material. And I think the photograph on the right shows that. So that's quite a depth of organic material of a peat there sitting on a mineral subsoil. And it's that, accumulation of material is the word. And as that material accumulates, it can it can accumulate to quite significant depths. In Ireland, we've a high proportion of peats, you know, ourselves and the Finns and the Estonians maybe, and the Scots would be up around a similar level in terms of the total area of the land surface. We have 1.5 million hectares of peat soils, 21% of the total land surface area. So 1 in every 5 hectares in the country is peat. So obviously it's a significant land cover or soil type that's out there. Within that organic material then that has accumulated, as I've described, up to many meters in places, you know, that is the carbon store. So it's decayed plant and animal life, as I said, or partially decayed plant and animal life. And it's estimated that 1.5 million hectares stores about 2.3 billion tons of carbon. So when we talk about you know, annual emissions rates from the country, be it from agriculture, be it from the other sectors, you know, there's a certain number of million tons in a year. Annually, there's a total emissions rate, obviously, as we're well used to hearing about. But you know, you're talking about 2.3 billion tons of carbon here stored in the peat soils. And as I said there, the estimates vary, but globally 375 up to about 750 billion tons of carbon globally, even though peats would store about would cover about 3% of the land area globally. They're storing between 20 and 30% of the carbon, of the soil carbon globally. So they're packing a punch in terms of the rate of carbon storage. And that's why they have a significant role, I suppose, in the whole climate question and the management of that. So that's peatlands. What to be classified as a peat soil? Again, definitions vary, but the definitions we generally work off is a soil that has at least 20% organic carbon, which is about 34% organic matter content, and a minimum thickness of 40 centimeters. So you can have, you know, as I'll discuss in a minute, you can have organic or high organic matter content soils that mightn't be fully 20% or mightn't be fully 40 centimeters depth. So there's still a good level of carbon storage within those soils. But you have to meet both criteria basically to be classified as a peat, and that thickness of 40 centimeters, as I said, you have peats that are, you know, 8, 10, 12, 15 meters deep in places. So you know, that 40 centimeter threshold is quite easily met. In other scenarios, at the fringes of peatland areas or large bog areas, you'll have that transition out into a mineral soil. So you'll have the organic layer effectively thinning as you move away from the core area or the central area of the peatland. So that boundary is what we're trying to define at times, which gives us that uncertainty that's often there around the area of peat that's in the country, and you get different estimates because it's not always known where that transition, where a depth of peat is 41 centimeters and 39 centimeters for the sake of the argument, and moving in and around that zone. So it can lead to quite a bit of uncertainty around the fringes of the peatland areas. Just to again provide a bit of context, the mineral soils, most of the soils in the country would fall under this banner, and just to provide context about what I'm about to move on to in terms of some of the other soils. But mineral soils are derived from mineral matter. Terms would be all familiar with: sand, silt, and clay, larger particles, you know, stones and gravels and so on. Generally have a low organic carbon content, less than about 5%. So the pictures there will tell you what we're talking about, I suppose, to a degree. You don't have the same dark color as we were looking at in the previous slide. The reason I'm introducing that, I suppose, is just to flag that we also have this halfway house, I suppose you could call it, what are termed the organo-mineral soils, and there's 2 broad categories there, which I've just highlighted. And I suppose the photographs, I suppose, maybe to jump to the photographs first. The first slide I showed you with the peat soils was that very distinctive dark color, all the way down through the profile. The second slide I showed you know, a more typical mineral soil profile. And what you're looking at there in those photos is as I described, a halfway house. It's mineral underneath that dark colored organic layer. So these are soils with high amounts of organic matter, so high carbon storage, relatively speaking, compared to a normal mineral soil. 2 categories there that I've highlighted: histic soils. These meet the criteria in terms of there's a peaty layer there, there's more than 20% organic carbon, but the depth isn't at the 40 centimeters. Generally classified within that 7.5 to 40 centimeter range. Humic soils then are soils that contain an A horizon or a surface topsoil horizon with significantly more organic matter than mineral matter, and there's a range of different criteria then, which I haven't got into or just don't have time to go into, but the amount of organic carbon that's there by definition varies with the amount of clay, and there's different criteria. But again, high amounts of organic matter, and it's a bit of in terms of the policy around these isn't as clear. For the mineral soils, we're fairly clear what the management should be. For the peatland soils, we're fairly clear what the management should be. But for these in between soils, there's still a good bit of discussion around that and how those should be managed going forward. But just to highlight that there is three categories effectively when we often consider just two. As is often the case with soils, there's a good bit of complexity there that tends to get maybe brushed out when the policy side of things comes into play. Okay, so to jump back a bit, I mentioned 1.5 million hectares. Obviously, there's a range of different land uses in place in that, and there's a number of different relatively recent references that I've given there. From O'Sullivan in 2018, there's a breakdown there in the top left corner in terms of a table. What we're looking at there is the different land use categories of that 1.5 million hectares approximately. So you have natural peatlands covering 270,000 hectares approximately, cut over peatlands 612,000 hectares, forested peatlands just north of 300,000 hectares, farmed peatlands 295, industrial cutaway peatlands 70,000, and rehabilitated cutaway about 18,000. So the farmed peatland, and it says grassland and cropland there. You know, the vast majority of peatland under agriculture is under grassland. So it's 295 there. The general consensus is that range falls in the 300 to 350,000 hectare range. You see the pie chart in the bottom left from David Wilson in 2021. Again, agriculture there in green. We under the remit of agriculture, obviously not all that 1.5 million hectares is included, so we have a portion of that. And the map on the right from Habib and Connolly, a paper that was published last year looking at peat land use mapping. Again, it's hard to make out maybe depending on the size of your screen, but grassland there is in the green color, forestry in yellow, residual peat in an orange color, and industrial peatland in a red color. So you can see there's trends in different parts of the country. The grassland tends to be concentrated maybe more so around the Midlands, and so on. But again, the agricultural sector has remit over, I suppose, the farm peatland as it's classed there, or the grassland peatland, which is a subset of the full 1.5 million hectares. The national inventory, I suppose, is the go-to reference for a lot of these figures because it is the EPA, the Environmental Protection Agency, are responsible for producing the national inventory every March or April of every year. And you know, when all the estimates are taken into account, that is the report, I suppose, that puts their arms around all the different estimates and all the different information and pulls together a reasoned estimate of these of the different definitions. So what they have under the grasslands heading is 3.89 million hectares of mineral grassland and 0.339 million, so 339,000 hectares of organic grassland. So that's really what it boils down to in terms of what I'm talking about today in terms of grassland peat soils. That 339,000 hectares. As I said in the previous slide, the range is generally recognized in that zone of 300 to 350,000 hectares, and the EPA or the National Inventory have settled on a figure of 339,000. Okay, there's been other efforts then. This was Stuart Green, a Teagasc colleague, looked last year at land use of organic soils under agriculture. He combined, I suppose, information from the land cover map, Talcheran, or ordnance surveys as they were known, Teagasc soil maps, and the land use or the land parcel information system to look at a breakdown of that area. His total, if we look over at the right-hand side of the table, 336,000, so very much in that range again of peat soils, organic soils under agriculture, and he's broken that down into the peat types or the bog types. Raised bogs 220,000 hectares, blanket bogs 105,000 hectares, and fen peats just over 9,000 hectares. So again, there's a number of different efforts being made at the moment to try and refine and try and define, I suppose, what's going on in terms of the different uses, I suppose, or the different scenarios in terms of peat soils under agriculture. There's a breakdown there in terms of what those categories mean. Fens are bogs that form that are generally formed under the dominant influence of groundwater. They're relatively shallow compared to some of the others. Average depth is 2.2 meters. I'm not going to read these definitions in full, but they're just there for information. Raised bogs generally found in the midlands, develop generally over the fen bogs, with that, I suppose, characteristic dome-shaped surface, and they're deeper, 7.5 meters on average, and blanket bogs then generally in mountain areas or in the west of the country. Generally high rainfall or very high rainfall areas, particularly this year. I suppose we can all relate to that. Shallow, relatively shallow. They're a blanket, as the name suggests, like layer over the surface of an underlying mineral soil, and an average depth of 2.6 meters. So they're just broad classifications in case anyone is wondering what the breakdown is in the table. So, and this is maybe, if you're not confused already, this is maybe where things start getting a bit confusing, because I've broken the inventory down, because there's been a recent change. So as I mentioned earlier, the national inventory is published every March or April, and this March was no different. The 2024 national inventory was published. And there's quite an adjustment there in terms of the grassland figures in that, as I'll go through for the next few slides. But up to this point, and I suppose policy around the management of these soils up to this point has been dictated largely by this table. So what this table that we're looking at now is the LULUCF emissions categories. So land use change and forestry, the various different emissions in the units as million tons of CO2 equivalent per year. This is effectively a league table. You can see there grassland is very much at the top of that league table, 7.09 million tons of CO2 equivalent annual emissions per year. That's made up of, if we look at the box on the right-hand side, about approximately 9 million tons emitted from drained peat grasslands, and 2 million tons sequestered by mineral grasslands. So 9 minus 2 for round numbers is approximately the 7 you're seeing. And as you move down along the table, then you'll see other different categories. You'll see forestry there is a negative figure, so it's generally sequestering. Harvested wood is the same, cropland is the same, those are negative figures. And there's some other emissions categories there, wetlands, settlements, and other land. And the total there is 7.3. And obviously the 7.09 is the vast bulk of that. So that's the basis of the policy around the management of these soils heretofore. And that's what I'll move on through the next few slides, in that I suppose under the influence of that table really is where the policy has been made over the last few years, and the numbers that are in use there. Those emissions estimates in terms of so it's to focus on the grassland peat soils, that 9 million figure is coming from all those elements you're seeing on that graphic on the left-hand side. The extent of peat, how much peat is there, land use, how much of it is under grassland and under agriculture, the drainage status of those of that land use, the nutrient status of that land use, and associated emission factors. All of these elements are subject to much ongoing research, because there's a good bit of uncertainty around most, if not all, of those. So heretofore, in terms of the calculation of that 9 million figure, the grassland areas, as I say, taken as 339,000 hectares. The IPCC, the Intergovernmental Panel on Climate Change, laid down the rules, obviously, in terms of how the inventory is to be assessed. And for those soil types, for peat soils under agriculture, if the water table level is classed as unknown, then they are assumed to be deep drained, and they're assumed to be consistently drained across that full 339,000 hectares. That's associated emission rate of approximately 26 tons per hectare. So how much carbon is emitted per hectare per year from that scenario of there being a certain amount, 339,000 hectares of grassland peats, and all of those being deep drained. And you multiply The 26 by the 339, which will give you the 9 million or thereabouts. And I've used slightly round figures, so don't be too worried if you don't land on exactly 9, but that's the broad idea in terms of how that figure is calculated. I suppose drainage has been mentioned there in terms of how the IPCC defined the management or the approximation of emissions from those soils. And this is well established that it's water table depth within the organic or peat soils which controls whether accumulation or decomposition of organic matter is dominant, and whether sequestering of carbon is dominant, or whether the loss of carbon and emissions are dominant. So if you drain these soils, then there's a greater level of emissions from them. So if we're taking that all those soils are drained or deep drained, then obviously that yields a very high level of emissions. So the second bullet point, I suppose, reflects the first one there. The long-term stability of the peat is very sensitive to any changes in hydrology brought about by drainage. As the water table depth is increased, you promote aeration close to the surface, which increases decomposition of the organic material, which, as I said earlier, is the store of carbon. So material that was heretofore held in suspension, I suppose, in terms of decomposition, is now aerated and now starts to decompose, and all the carbon is lost to the atmosphere. So you get the emission there, as I said, greenhouse gases, GHG, carbon dioxide, nitrous oxide are released to the atmosphere. So that's the mechanism by which the carbon is lost in the drainage scenario. The water table is lowered, the soil becomes aerated, and decomposition takes over, and the store of carbon is reduced. So again, to follow on from that, there's been a number of documents here. Some of you will be familiar with these. There's a Teagasc document there on the left, which is the marginal cost curve for greenhouse gas abatement. The other ones are government documents, climate action plan of the last 2 years, 2023 and 2024. All of these, I suppose, have treated very much the organic soils as has been put forward in the last few slides, that water table control and management of water table is the best way of trying to reduce or mitigate against losses from these soils, and that's obviously the policy that's in place. In terms of water table control, there's advantages from a greenhouse gas emissions viewpoint in terms of draining wet mineral soils, which reduces the nitrous oxide losses from those soils. And as it's stated there, water table manipulation of organic soils, so controlling the water table or maintaining a relatively high water table on organic or peat soils to prevent the losses that I've described on the previous slide. The most recent climate action plan, which was published at the end of 2024, the end of 2023, I should say, for 2024, outlines those objectives that 25,000 hectares of drained organic soils would be subjected to what they classify as reduced management intensity by 2025. And by the end of 2030, that figure would be 80,000 hectares of drained organic soils with reduced management intensity. And when you read the fine print of the climate action plan, reduced management intensity is effectively water table management in general. There is some mention also of reduced fertilizer use, but all the other criteria related to hydrology are related to water table management. So I suppose that was the status quo heretofore, and it was something, I suppose, that we had been aware that there was a certain amount of uncertainty around. So in the last number of years, we've looked at, I suppose, where the starting point should be in terms of what level of drainage is actually out there in practice, because we're, I suppose, dealing with this issue of soil hydrology for a number of years now, myself and other colleagues, looking at farm scale drainage. And I suppose we had the view very clearly in our own heads that, there is a very, it's very technically difficult and expensive to drain peat soils. Where we have high level, unless you have high levels of investment, you don't effectively control the water table, and unless you have a fairly significant maintenance regime, the functionality of those drains reduces over time. So there needs to be a high level of investment to begin with, and a continuing level of investment. And from what we knew and from what we could see, that wasn't always the case. Certainly not around the full area of the 339,000 hectares that we have been talking about. And we were asking ourselves that the bottom bullet point there, the bottom question: what proportion of the grassland peat area is drained effectively? So again, the national inventory is under the remit of the IPCC, and they have to follow the ground rules. So if there is little or no information around grassland peat soils and their drainage status, then they all have to be assumed to be drained. Whereas we were of the view that that wasn't justifiable, and we were, I suppose, for a long number of years, recent years, discussing how we would prove otherwise. So this, I suppose, the fruits of all that work and those various discussions was ultimately last summer. We published the paper that you're looking at there, titled "Drainage Status of Grassland Peat Soils in Ireland: Extent, Efficacy and Implications for Greenhouse Gas Emissions and Rewetting Efforts." Myself, Lillian O'Sullivan, Conor Bracken and Owen Fenton were all involved. And I suppose what ultimately we were doing was challenging that assumption that the water table level is unknown. And the way we did that, I suppose, was looking at historical information, and we're lucky within Teagasc and the forerunner to Teagasc, which was on First Chaluntis AFT. There was always a good team involved with soil management, soil science, soil hydrology, and there was a good level of work done, particularly in the 60s and 70s and 80s, in terms of looking at how effectively to drain soils, all soil types, mineral and organic. There was grant aid available at the time. The drainage of land was very much being actively encouraged to try and increase output and production. And as a result, there's a huge amount of information available from that time. So basically what we did was gather that evidence, put it together into a more formal argument in terms of, it wasn't fair to say certainly that that you could class the drainage status of those soils as unknown, because we had very much a clear idea of what was happening out there from historic work and our own work. And we proposed changes for inclusion in future inventory updates. So I suppose that at the time made a few waves and was picked up, in various places in terms of the outcome or the implications of that work. And that was, as I said, last June or last summer. But effectively, as things stood with the national inventory, the ball was very much not in our court. We had proposed these changes, and then we had a number of discussions and follow-up meetings that led to the changes that were recently published. So it was only, as I said, last June when the work was done or published, but it was only in the last month, March of this year, when the inventory was updated, that those proposed changes were reflected in the inventory. So you're seeing there on the left the table we already looked at, in the middle column now, the data we already looked at, and on the right-hand side column, the updated information. So you can see there that the total grassland emissions is gone from 7.09 down to 2.48 million tons of CO2 equivalent, and the total LULUCF, land use change and forestry emissions are gone from 7.3 down to 3.98. There is also reclassification under the wetland category, so you'll see a very significant increase in the wetland category, 2.05 up to 3.76. But you can see the reflection there in terms of the work that was done over the last number of years and how that has changed the inventory. And obviously there's still a very large number. It's still 2.5 million tons is effectively, I should say as well, probably to clarify, 4.5 million tons of emissions approximately from the peat soils, and you still have the 2 million tons being sequestered by the mineral soil. So 4.5 relative to 9 is obviously a reduction, but it's still a very high number. So there's still obviously a range of policy and management decisions to be made around trying to reduce that number going forward, but it gives us a more or a clearer starting point. Okay, so just to mention, I suppose, as well, and these particularly the nature restoration law was very much in the news recently and in the last year and early parts of this year, and I've matched it up with the climate action plan here. What I've put forward there on the table is the proportions and all these I suppose management decisions are in these reports, be it the climate action plan or nature restoration law, are based off proportion of total land area. So that's the way I presented the climate action plan on the left, 2030 in the green color, and 2050 in the lighter green yellowish color, the targets up to those dates. So you can see the climate action plan based on the previous inventory was targeting 80,000 out of about 339,000, so that was about 25% in the green by 2030. The nature restoration law, as was originally proposed, is in the middle there. It has been reduced in scale or in scope, but they were proposing, less than 10% by 2030 and about 35% by 2050. So that that isn't the scale, as I said, anymore. So the current nature restoration law is proposing less than 10% by 2030 and less than 20% by 2050. So I suppose what's interesting for me there is the climate action plan proportions are more ambitious, certainly in the short term, than the nature restoration law. But the nature restoration law, I suppose, took on, was very much in the news and in discussion over the last while. So that just to compare and contrast, what's there as well is the nature restoration law, what they propose in terms of I should say the first number of columns there are the potential or the proportion that should be subjected to water table management or rewetting, and the nature restoration law is a further category, which is restoration of those organic soils in agriculture. So again, the definition of what that will mean for various different starting points, I suppose, is what needs to be worked out going forward. In the rewetting space, and rewetting is a controversial word, and particularly in the last couple of years, I suppose that there tends to be a view put forward from some circles that rewetting of farmland is creating lakes and is flooding farmland. That isn't. I'm not sure where exactly that's coming from. The rewetting of industrially of peat that was extracted industrially, the likes of the Borden and Mona sites, are being rewetted up to a level where they're at a flood level, but that's not what has been proposed for farmland and never was. Rewetting as defined by the IPCC is the blocking of artificial drainage features and the raising of the water table. There is no diktat that it should be at a particular depth or a particular level, and it's certainly not dictated that it should be at a flood level above the field surface. So what we're looking at with this project, which is Department of Agriculture funded, the map on the left shows the sites or the location of some of the projects that were tied in with largely EIP projects that are linked in with this program, and it's looking at current drainage status. Again, the first question we've always been asking is, you can't assume, particularly on a farm scale or a landscape scale, what the water table is doing or where it's at. There's obviously seasonal changes and spatial changes and everything else. So what the current drainage status is obviously very important as a starting point. And then if we were to control the water table, where is the best place to do that? What would that cost, and what is the wider impact? So that project is up and running now since 2022 and will run until 2026. As I mentioned already, we're targeting that grassland on peat, that 339,000 hectares, looking at the rewetting question. And I suppose to jump to the third bullet point down, from our point of view, we need clearer information in terms of the policy going forward around these soils. And this is why this project has been funded, to look at where such works would be appropriate and where they're feasible, how, the simple practical questions of how you would actually go about raising the water table or reducing the flow from drains, what the benefits and impacts of these works would be, in terms of the emissions question, obviously, and in terms of the implications on the land itself and on surrounding land. There's a number of different sites there pictured on the right-hand side. The colourful markers on those field sites are various different monitoring points or measuring equipment that's installed. We're measuring water table depth, which is obviously the key metric. We're measuring soil moisture on a range of these sites. We're measuring flow and discharge from the sites in the open drains. Rainfall, how much is falling in the particular sites, that will obviously dictate as well where the water table position is and the discharge. And a subset of sites being looked at in terms of water quality. And you can see there, I suppose, again, the pictures indicate the scale of that in terms of what's there in terms of different levels of equipment on these sites. All the data that's being collected is fairly high resolution. So data every 15 minutes in terms of water table depth or rainfall or discharge from the drains. And with that data, as I said, it's a 4-year project. It's a fairly extensive project, and we've 12 sites in play across the country, mostly in the Midlands. And we're looking at that idea of where is the water table to begin with, and how much say do we have in where it ends up, or how easy or otherwise it is to manipulate it. There is going to be differences, or there is very clearly already differences between sites in terms of the different peat types and the different management heretofore, and the depth of peat, the location of drainage features, the general seasonal effect, which has been significant in the duration of the project, because we started, as I said, in April 22 when we had extremely dry conditions for a couple of months, and then we had a wet winter, and then you're broadly familiar with him, but how last year went in terms of the scale of the rainfall in the last couple of months in particular. So we're getting that effect over different weather conditions, and as I said, what the natural position of the water table is, and what we can do if we try to manipulate it. And as usual with soil hydrology, we mightn't have as much say as we might like to think, and certainly in some sites or others. So that's the key question: where can we have an effect, and what is that effect if we can manipulate the water table? The last slide, just to highlight as well, a recently funded project which is just getting off the ground at the moment, which is looking at the whole question of the management and current status of these peat grassland soils. Detect is the name of the project. It's looking at drainage status, detection mapping for organic soils, for the NIR, for the National Inventory Reporting requirements, to try and, as best we can, support. Okay, so we've already established that there isn't as much drainage probably out there as was previously assumed, where there was no information available in that regard. Now, I suppose the question is, where are the well-drained soils, where what is the effect of different management in different parts of the country, and to try and establish as best we can what the different conditions are in terms of current status of these soils, with the broader aim to refine emissions estimates and reduce total emissions, and running at a landscape scale. The work heretofore, the likes of the Rewind project, is generally at paddock or farm scale, whereas this is moving into a wider scale to try and assess some of those questions, and up to a national scale ultimately would be the aim. So that's as I said, there isn't a whole lot there, because the project has just started 2-3 weeks ago, officially the 1st of April. So that's all I have in terms of slides. So I'll pass back to Mark, and we'll probably take a few questions. Thank you very much.
Thanks very much, Pat. Thank you for excellent slides and walking us through those. And again, they will be available on our website over the next few days. Pat, so if you wouldn't mind just stop sharing your screen there,
yeah,
and we can get into some of the questions. But obviously, this is an area of great interest to farmers across the country and policymakers, given the importance of these types of soils in terms of carbon sequestration. Question coming through here in relation to the industrial peatlands that we have in the country, and these are being reduced, or the milling has ceased in most of these bogs at this stage. Is there any estimate on how these unused bogs will contribute to capturing carbon, and when they will stop emitting CO2 as they reflood these areas? So, what role are these bogs going to play in reducing those emissions at a national level?
Yeah, so that those would fall, if we go back to the land use categories that I highlighted, those would fall under the wetlands heading as opposed to the grassland heading that I was largely presenting. But there is, like, Boardnamona would have very ambitious targets, and you know, those that are familiar with peatlands that are run or owned by Boardnamona would see that in action already. You know, there's huge, you know, thousands and thousands of those hectares. So Boardnamona own approximately about 80,000, or responsible for about 80,000 hectares, mostly in the Midlands, obviously. And you know, large proportions of that have been prescribed or have been assigned towards blocking drains, raising the water table, rewetting. In terms of how long before they contribute, I suppose the view would be taken once you raise the water table. You know, there is more or less an instantaneous effect in terms of once that water table rises and is maintained at a higher level. The process that I described earlier in terms of the aeration of that peat and the loss of that carbon store is effectively stopped. There is, in the short term, a question around some methane release, but even that is dwarfed in terms of the savings in terms of carbon losses. So it is a fairly swift turnaround in terms of that there is. Look, I suppose the longer it goes on, the better the effect is in terms of reduction of emissions, but there is an initial or an instantaneous effect as well. And as I said, they'll be significantly reducing emissions as time goes on, as more and more of those areas are taken out of commission or re-wetted.
You just mentioned that difference between the wetlands and grasslands. You mentioned there's a few people asking the question of why did those figures increase so much after the 2024
Yeah,
adjustments?
so like the grassland category, and I'm not fully au fait with the particulars, but there was a reclassification in terms of different land use types and or different use cases under that wetlands heading. So there was more moving into a higher emission rate, effectively, or less in the lower emission rate. So they were switching around in terms of the different categories and yielded a different estimate.
So when you say use cases, what do you mean by that?
So in terms of the grassland categories, for example, I mentioned the rate of approximately 26 tons per hectare of emissions. So if all are considered drained, what has happened in the grassland case is they're not now all considered drained. So you still have emissions from those, but they're not anywhere near the rate of 26 tons per hectare. So from my understanding of the wetlands, it's the same kind of idea. They've moved into different categories, different proportions of that wetland category, that land use have moved into different categories, having higher emission rates.
Thanks, Pat. So do keep the questions coming. We have quite a diverse set of questions coming through to you here, Pat. So and Pat Murphy, you monitoring closely.
I suppose there's a couple of questions on I suppose land use, and there's a question there: would forestry plantation using minimum cultivation on drained peats help restore soil carbon stocks over time? I think that's another fairly controversial area.
Yeah, so there's a large amount of forestry, obviously, on peatland, and Boardnamona isn't the biggest state owner of peatland. It's Coillte, by a long way. So that there is obviously a huge amount of forestry on peatland, or historically there has been. But there is emissions associated with that, because you have the same, you know, the root structure and the trees themselves would have an impact on water table. So there would be a change there, an effect relative to natural peatland and emissions associated with that.
I think the assumption is that the forestry acts as in effect a form of drainage of those soils, and that's the problem there. Another question in relation to the use of the potential use of multi-species swards on with extensive rooting systems, but the assumption there would be that the multi-species sward, particularly if you have clovers and some of the plants that we use in multi-species sward, they require high fertility levels and generally higher pHs. So is that a runner at all?
Yeah, that's a question. I suppose it's more general as opposed to the organic soils, but on the mineral soils, that's something that's certainly been looked at in terms of greater biomass and greater carbon storage from, you know, a denser root system or and so on. So yeah, that's not necessarily suited to the peat grasslands.
So just can you say something about the effect of the rewetting experiments on methane emissions?
Yeah, so as I mentioned earlier, there is broadly, in general, a reduction when the water table is raised. There is overall, or there's a net reduction, but there is an increase in the short term, and that's quite well established in terms of methane emissions. Over the first particularly over the first early years, 1, 2, 3 years. But again, it's dwarfed by the gains, or the net gain, in terms of carbon reduction, emission, or reduction of carbon emissions, I should say.
And are you saying there that losses in methane that will reduce over time? Is that the inference I'm getting from you there?
It's relatively short-lived. Yeah, it's
Okay.
the initial couple of years.
Have you any idea how many farmers are farming the 350,000 hectares of peat grasslands?
I don't have a number for that, Pat. No. Off the top of my head, I'd be telling a lie if I said I did. Off the top of my head, no.
Does the grasslands category differentiate between lowland peats and intensive and extensive grasslands? So is there, I suppose, a further categorization between, I suppose, lowland and upland, and intensive and extensive?
Yeah, and that's what I was trying to show there. And there's further breakdowns available in terms of various different definitions and various different classes. I broke it down there by the raised bogs, the blanket bogs, and the fens, and they would split to a degree in terms of lowland and highland and level of intensity. But there's different classifications certainly being looked at in terms of the future management of these. I suppose we need to know as much as we can in terms of what's actually in play, in terms of what that might look like in terms of future management.
Just looking at the policy side, Pat, for a moment, do we know when this sectoral target for LULUCF will be decided, and what it could be? Is there any indications? This is a question coming through.
Which Pat? Sorry, Mark.
Sorry, Pat Tuohy. Yes.
Yeah, that's one we've been waiting for, I suppose, and that there doesn't seem to be coming to seem to be bearing any fruit in terms of the targets being finally finalized. So we're waiting to see on that one.
That's ultimately the EPA or government decision, I guess. That will be made there. Very fair enough. Will there be restrictions on farmers on peat soils in the future as regards farming practices, maintaining existing open drains, cleaning field drains, and reseeding, etc.? So do you foresee that sort of change in practices, perhaps voluntary agri-environmental schemes, or?
Yeah, I think it'd be more in terms of voluntary schemes and what's available in terms of, straight away. I think the recent changes have meant that there's a view taken that there's already a fair proportion of that land category that's already acting as rewetted, or certainly seasonally rewetted. So as I was getting at earlier, a proportion of the total is now a smaller number if we take the same methodology from a policy point of view. We can only assume going forward, but I don't see I see this more as a voluntary basis, certainly in the short term or short to medium term, in terms of how those hectares are recruited into such a change in management.
Yeah, and there are already measures, Pat Murphy, aren't there, within the acres program there to low input grasslands and peats and so forth. There are some measures
and around the cooperation projects in the uplands. A lot of that is focused around protection of those habitats or those peats as well. Yeah. There's a question there: is the aim of the project not only to look at the manipulation of the water table and the carbon emissions, but to look at agricultural practices that still can occur on these areas when the changes in water table has occurred, and what the impact of the water table changes is on the potential for agricultural land use?
Yeah, to a degree. Yeah, look, the core focus is water movement and hydrology, but obviously that's the implication then in terms of if it was effectively a longer winter or a shorter dry period when the water table was at a level that would suit grazing or so on, then yeah, obviously those implications are being looked at as well.
And I suppose another question there was that the assumption of the high rates of loss had the potential to lead to a carbon payment for those farmers if they reduced it. But does the reduction in the assumed or the now measured levels of losses kind of undermine that potential a little bit? Is it a two-edged sword?
Yeah, I suppose you can't win, Pat. Is that
Yeah,
the answer to
exactly.
that one? Look, I suppose our role as researchers is to try and provide as much clear information and understanding as we can in the topic, and you know, it is what develops after that. Then our own policy is a different day's work.
Yeah.
But there certainly changes in terms of how those that category, land use category, is being viewed going forward.
And I suppose a little bit of work needed there to look at the farming practices in those areas.
Absolutely, yeah.
A question there: do grassland peats not re-wet themselves every winter, and the water table rises, soil becomes saturated? How much of that is what I suppose is contributing to that change from what you had? So without management, have we progressed a long way towards achieving what we need to achieve there?
Yeah, and that's a very good question, because that's basically the core of our argument, that you know you don't have to do too much driving around this country to find yourself in a wet peatland in you know particularly in the winter time, and we've had a very long winter as we speak. Hopefully we're coming to the end of it, looking at the forecast, but yeah, that's the key issue. You know, how much, you know, the emissions on these are based on a mean water table over the year. It's a very valid question to ask across all the different range of peats and depths of peats and historic management and so on. It's certainly not fair to prescribe that they are all at the same water table. So that's part of our work has been trying to introduce some subtlety in how those figures are established, and then going forward with current and future projects to try and estimate as best we can, you know, what is the mean water table. Obviously, the person who asked that question is very clear and very correct, is that there is a level of saturation for long periods of the year on a large proportion of these soils. So to try and come up with a more reasoned mean water table depth really is what our work is about predominantly at the moment.
So a couple of questions in relation to the wetland as well. First one is that predominantly a nitrous oxide issue in those, or is it a methane and carbon dioxide? And I suppose a second question on that is there a degree of uncertainty around that? So in other words, is there a job of work for you to do when you finish all your work on the peat soils to move on to wetland soils?
Yeah, look, I suppose there is, as I said, I'm not as directly involved in that side of the house, but there is obviously refinements within that category going on, or have been, as I showed there in the previous slides. And to come back to the first question, whether it's nitrous oxide or methane or carbon, you know, in different circumstances, you know, there's different losses, but it's broadly the same mechanism as I described in one of the earlier slides. The water table is being drawn down, and the material that is storing the carbon is being decomposed and lost. So it's a combination of all the different of those different emission categories.
Pat, you mentioned the Finnish and other countries across Europe do have peat deposits or peat lands. Are they taking similar approaches, or do we have any insights as to how they're tackling this issue?
Yeah, and it would be very similar historically. They would have been, you know, actively encouraged to you know, you use the various different peatlands for forestry, or for harvesting, domestic turf cutting, or for industrial harvesting, or for agriculture, and have produced, you know, various different land uses on the peats, the same as ourselves, and are now kind of asking the question in terms of what is the future use case for these soils, and how do we manage them. And very much, and if you look through the research side of things, very much asking similar questions in terms of, what are the drainage networks that are serving these soils? How effective are they? The question was asked there a minute ago, what is the seasonal effect here on water table? If we get a summer like 23 versus a summer like 22 or a summer like 2018, there's differences there in terms of the emissions. So does a change in climate impact or a more extreme climate impact on how those soils are behaving in terms of emissions going forward? So they're in a very similar position. We're not unique in that regard. I suppose we're in that category of having a very high proportion of peats, but the same questions are being asked about peats around all parts of the world, really.
Pat, maybe a 30-second answer to a question that probably could take hours is what has happened to the water quality in terms of where re-wetting has been implemented?
Yeah, I suppose that there's no straightforward answer to that. As I said, you could give another 2-hour talk on that. Varies with nutrient status, varies with management, and varies with I suppose the pre-existing hydrology status and any changes to that hydrology status. So there's no one answer to that, I'm afraid, and it's certainly not in 30 seconds.
Okay, another webinar on that at some point.
Yeah.
A question. We have organic maps that Teagasc EPA have produced. Are they out of date? Do they need to be revamped, or are they reasonably okay for continued use?
Yeah, no, I mean, the mapping, there's always certain level of improvement can be made, but those maps are quite appropriate for what they're being used for. And in terms of, obviously, there's the obligation now to test, but if you can, they're assumed organic unless they're tested, and if you can test and show they're not organic, then you're not restricted, obviously, to the Index 3 rules in terms of nutrient application. So it's a matter of testing and establishing whether that boundary is actually where it is, or where it's proposed to be on the map, or where it is in practice is a matter for testing anyway. So there's that is built into the system that people can test and establish whether they're in or out anyway.
And just a clarification that regularly comes up when we're talking about re-wetting, we're talking about just organic soils, that the impact on mineral soils of drainage is largely to reduce emissions rather than increase. Is that correct?
Yeah, so there's still, from a greenhouse gas point of view, lowering the water table in wet mineral soils has a positive outcome because you reduce the nitrous oxide emissions. So they're very, very opposite in that regard. So as I said, yeah, lower water table management is very much focused going forward for a subset of the organic soils, certainly not mineral soils.
Okay, we're just coming up towards the end of our session this morning. So I want to say thank you, Patrick, for coming along to this morning. Lots of interesting questions, getting very technical questions coming through there. So I'm sure, Pat, if people have follow-on questions, that they can contact you if you have more technical questions that you'd like to put to Pat. Just to remind you that next Thursday, Teagasc is hosting a webinar in conjunction with Your Agri, where we're going to be exploring inspiring stories of rural entrepreneurship and innovation in Ireland. So do join us if you are free at 10 o'clock next Thursday. We'll be joined by Barry Caslan, who's Teagasc Energy and Rural Development Specialist, Teresa Roach, who is a rural entrepreneur, along with Nick Cotter and Noel Casey, who are also rural entrepreneurs. So just to flag that's coming up next week. And next Friday then, we're going to be joined by Daniel Henn, who is a PhD student working between the University of Limerick and Teagasc, who's going to be talking about the impact of clover, along with other measures on land use and net zero emissions from agriculture by 2050. So we have a very strong theme of carbon emissions and looking and sequestration during these few weeks. So we do hope you can join us next Friday for that. But until then, Pat and Pat, thank you both for coming along today. And thanks to Yvonne Maher in the background, who's helping us with all of the scheduling and organization. This doesn't happen by accident, I can assure you. So big thanks to the broader team that's involved in making all of this happen. So until next weekend, next week, have a good weekend, and hopefully it's a dry weekend for everyone. So take care. Bye bye.